Okay, so today we're going to end up the semester with a brief introduction to vectors and dot products. It's a fairly short assignment. As I mentioned before, if we had more time this semester, we'd probably spend more time on vectors, but maybe not. We would spend it more on, do more with identities. We never work with those sum to product and product to sum identities, so maybe that's what we would do if we had more time. But what the heck is a vector? Well, it's a topic from physics, and a vector is used to represent magnitude and direction. By magnitude, it's a number. To distinguish between a vector and just a plain number, we're going to call a plain number a scalar. A scalar is just a plain number. That's what we're going to call versus a vector. A vector is both magnitude and direction. 32 miles an hour, that would be a scalar. 32 miles an hour in an east direction, that would be a vector. Okay? So we have vectors and we have scalars. Vectors, magnitude, and direction. The classic example, a speed of a car, 45 miles per hour. If it just says 45 miles per hour, that's a scalar, whereas cars going 45 miles per hour and headed west or north, that's a vector. To represent vectors, we use what looked like in geometry you would call them a ray. Remember some terminology from geometry that you may not have seen for a long time. A line has arrows on each side. A ray has a starting point and then an arrow on the other side. The standard form for plotting a vector, and we're going to use the XY axis because that direction thing, okay? The length of the vector is the magnitude. The length of the vector is the magnitude. And then you use the direction. Like in this case, this vector is going in a northeast direction. If I wanted to draw a vector, let me put in some let's assume each one of these little marks is 10. If I wanted to draw in purple the vector that represents 20 miles per hour headed in a north direction. Due north, 20 miles per hour, you would make, you can't really tell it, can you? You're making the vector, the purple vector, well, you can't really tell it's purple. It looks like I just made it long. 20 units long. Okay? So I went north 20 units. If I wanted 20 miles per hour east, it would go like this. Okay? Graphically. So when we're drawing vectors, we start the initial side at the origin, that's customary. And then to identify the vector, really all that matters is this point right here. Like what would this ordered pair be if it's on the x-axis and it's 20 units long? That ordered pair would be 20, comma what? 0. The purple one, I mean, here on the y-axis, what would that be? That would be 0, comma 20. If it were south, it'd be 0, comma negative 20, and so forth. So that's how we normally write a vector. But in order to distinguish that it's a vector and not just a plain ordered pair, instead of putting parentheses around it, the vector that begins at the origin and terminates at the ordered pair AB, these are parentheses, can be written two different ways. The notation I prefer has some braces that look like greater thans and less thans. I'm not just making a pointy parentheses. Okay? If you have this little notation around the ordered pair, that means it's a vector. Or it might be written with the I and J variables. It could be written like this: I plus B times J. And when you do that, usually a little line segment will be written over the I and J, or if you're typing it, you'll see the I and J bold. Ooh, that looks bad there. No line segment there. Show you what the heck I mean before we actually start doing some of these problems. Notice number 2, you're given two vectors, U and B. U is 2I, and V is 5I plus 8J. If you were going to draw those out, the ordered pairs, the I is going to represent IJ instead of X and Y. So we'll do number 1 in a moment. I'm going to do this one right here. Number 2. We were actually going to draw these things out. What do vectors U and V look like? Vector U, that 2I means, move 2 units to the right. It's positive, up 0. So it would be a real short little vector like that. There's a little arrow there indicating the way it's moving, not that it just moves on and on forever. So 2I is right here. To graph this 5I plus 8J, this will be a better example. If you wanted the graph of that, which it isn't asking for, okay, I'm just trying to show it graphically. If you're going to draw that vector, you'd plot the point 5, 8 as if it were an ordered pair, right 5 up 8, and there it is. So if you were told to find, say, the magnitude, that would be this length. Could y'all imagine drawing a right triangle and using the Pythagorean theorem? A squared plus B squared C squared. That's not what we're told to do here. Number 2, let me actually start what we're told to do. In a moment we'll go back to number 1. Problem number 2. We're told U is 2I and B is 5I plus 8J. When you're just writing like this, it's hard to bold stuff. So one way that people do that, like the U and the I were bolded, you'll see people writing a little arrow over it like that. This would be a V, and then the I. Now, if you put those little arrows, it sort of starts looking messy. Okay? Sometimes I write them, sometimes I don't. I just remember, okay, it's a vector. So let's see, what's problem A, part A says? Part A says 6 times U. Well, just replace the U with the 2I. This is where I'm really going to insult your intelligence. What do y'all think I'll type in this first box here? 12I? Yeah. What we're doing here, we're going to wow people with our terminology. We're multiplying a vector U by, what do we call a number that's not a vector, just a plain number? A scalar. Okay, so we're multiplying a scalar and a vector. Now B, so that was the answer to the 6U. B, let's see, what does it say to do? 6U plus 7V. So that's 6 times U, which we already know is the 2I. I mean, going to be 12I, plus 7 times V. Well, I'm going to just sort of adopt our algebra notation and put parentheses there. What am I trying to say we're going to have to do to the 7 here? Distribute it. So we would have a 12I plus 35I plus, what's that? Oh, 56J. So that's going to be, what is that, a 47I plus 56J. And that's what you would type in here. Oh, there's a part C that I hadn't seen. Let's see, part C. I'll do that in little P. So here's C. Ooh. Part C says V minus 7U. Well, the V is the purple one, so I'll write 5I plus 8J. You know what? I'm going to drop the little arrows just to make it look cleaner. Minus 7 times U. U is that 2I. So we have 5I plus 8J. Is that going to be a minus 14I? Then it's minus 14I, isn't it? Not thinking that that's the answer. What's the answer going to be? Negative 9I plus 8J. Negative 9I plus 8J. And surely there's not a part D on this, is there? Let's see. So this would be a 12I. This is a 47I plus 56J. And a negative 9I plus 8J. Number 3. Same type of problem. The only difference is it's written with just what I refer to as the ordered pair notation. Oh, are you caught up with me? So 3U. Could y'all do that without really writing anything down other than the answer? What's 3U going to be? 24 and 9. Just multiply both of these by 3. So this part, well, 24 comma 9. Now what about this multiplying by scalar and vector addition? Okay. Notice we could make all sorts of formal statements. The product of a vector and a scalar is our answer here a vector or a scalar? It's a vector. What about, we can make all sorts of fancy statements. Like on B, looking at 2B, the sum of two vectors is what? A vector or a scalar? Here's our answer. Right there. Oh, sorry. Okay. That's 6u, that's a vector. 7b is a vector. The sum of two vectors is vector or scalar? Vector, yeah. If it has an I and j, then it's a vector. Okay, same thing there. So let's see. On B, we have, I'll do a little writing on this one. 3u, that's the 24 comma 9, plus this black plus here is the plus that's right there. 4 times v. Let's see. Multiplying both of these by 4, what would that be? 16 comma 0. So we're adding two vectors. How do you think we would do that? What am I going to add with the 24? The 16. You just add the x components and the y components together. In the same way, if it had been I and j, you would add the i's together and add the j's together. So this is going to be, is it 40, comma 9? 16, excuse me, 24 plus 16 is 40. 9 plus 0 is 9. Pardon me. Let's see, what about part 3? Well, B is just the 4, 0. And minus. In red, I'm going to do the 4u right now. 4u would be, multiply both of these by 4, and what would we have? 32 comma 12. Multiply both of these by 4. And now, be careful with this minus. It applies to both of these. Instead of multiplying u by 4, if you had wanted to multiply u by negative 4 and then treated it as addition, that would have been a good way to do it. But I didn't, so it's 4 minus 32. That would be what? Negative 28. And then what's the next number I'm going to write? Positive 12, negative 12, or something else? Negative 12. 0 minus 12. You sort of got to distribute this minus the same way if you were using the I and j. You would distribute the minus. Now number 4. Do I need to do that one? Am I going to insult y'all by writing the answer down there? We're given a vector R. Oh, are y'all caught up with me? I haven't forgotten about number 1. The bad thing about number 1, well, let me do number 4, then we'll go back to number 1. Would y'all just multiply both of those by negative 5? What would we have? Positive 35 comma negative 35. Just multiply both of these numbers by negative 5. And why did I skip number 1? Well, the downside to printing these things out is you can't click the little magnifying glass and blow it up. When you're doing this on My Math Lab, when you're actually online, you can click the graph. There's a magnifying glass and it makes it bigger. What the heck? We're going to need to write this out. A and B. I claim it's going to be very similar to what we did here on number 3, except you've got to look at the graph to get that A and B. Get those ordered pairs. Here, this one is the one that says B. No, A. I'm going to magnify up here. I'm not magnifying on there. Just because, wow. I should have looked at this real close right before. Does it look like there's a dot? What is the dot? It's at the end. After the arrow, there's the dot. So is this a -1, 5? Is that what y'all think A looks like? -1, 5. B is a little easier to see, I think. 1, 2, then 1, 2. Is it 2, 3 for B? So A plus B. Well, it's this plus that. Just add the x coordinates, add the y coordinates. If we want to be more formal, you'd say add the I components and the j components instead of calling it x and y. Call it I and j. So what would this be? The first answer would be 1, 8. See how I got the 1 and 8? Yeah, so. For the A minus B, minus B. What am I going to have to do with that pink minus? In algebra speak, you distribute it. So it's -1 minus 2. So what's that first number going to be right here? -3. And then we have 5 minus 3. Is that a 2? And then the next one, I'll just write the answer down in a different blue. What do y'all think negative A is? If A is -1, 5, negative A would be +1, -5. It might look like I'm just popping the answer out, which is what I'm doing. Oh, I still haven't zoomed in. Unmagnify that. Oh, you still can't see it. That's number 1. Oh, by the way, while I'm thinking about it, I think all of you would have received an email on your WebDMC email that is a link. Huh?
So it's a survey?
It's a survey. So you got it at WebDMC? Yes? Oh, okay. Click on the link and do the survey sometime before the end of the semester. I don't know when the deadline is. I would think it's the last day of final exams. Do you remember when it said?
I thought it was like that week that we received it. Because I received it last week.
Oh, okay. So, I hope it's not too late. Okay, we just got a little thing saying two of you have done it. So, maybe if we could get 2 more people to do it, it should be good if we could double that number. Hopefully more than that. Okay? So if you haven't, logged into your WebDMC email, and I'm right, it's going to your WebDMC. It doesn't go to personal email, right? Okay. So, number 5. Okay, it's u plus v minus 5u. I'm sort of torn on how I want to do this. I guess I'll just write it all down. U is 5 negative 3 plus b negative 2 7. And you know what? I'm going to write this as plus a negative. I'm going to distribute the negative 5, the negative, right now. Go to v, go to u, and multiply both of these numbers by negative 5. That would be a negative 25 and what, a positive 15? Y'all see what I did? Just like when you first learned to work with negative numbers, you could write minus 5 as plus a negative 5. So plus, and I multiplied these numbers by negative 5. And now just go through, add up the x's and add up the y's, or add up the i's and add the j's. 5 plus a negative 2 is what, 3? Plus a negative 25, what's that, a negative 22? Y'all follow how I did that? Now what about the j's? Add those up. Negative 3 plus 7 is 4, plus 15 is 19. Any questions? Or why couldn't all the assignments be this painless? Well, oh my gosh. Maybe I should have done these first. Okay. 10, comma 14, write it in the form AI plus B times J. Do y'all need my help on that? What number am I going to put in the first box? 10. In the second box, 14. That goes back to this stuff I said at the beginning. It terminates at the ordered pair AB. It could be written either with the little ordered pair notation and the, what are these called? I call them less than greater thans, but I'm sure there's a formal name for them, because you're not really using them as less than and greater than, are you? Or AI plus B times J. Let's see now. Number 7, we actually got to type it in the form AI plus BJ. 2i plus 0 times j. Or if you just write 2i, my math lab will take either one. Now something new. This little dot here. That little dot, I'm going to define something called dot product. Dot product. If you have the vector AB dot CD, the dot product assigns a numeric value, or it equals a number. It equals a scalar, and there's a little bit of a formula here. A times C plus B times D. So for the dot product, usually when you hear people read this, they'll say U dot V rather than saying times, because usually when you think of times, it's multiplication of scalars. Okay? AB dot CD. You multiply the x's or the i's plus the product of the y's or the j's. On number 8, I'll just write it right here. It's U dot, oh wow, V. You multiply the x's. This isn't a great first example to begin with, is it? Because there's so many of the same number. So I'll try to color code it. The two numbers that I'm underlining in green, that's what I'm multiplying first. So that's going to give me a green negative 16. Oops. Is it still visible? Yeah. And then a plus. Negative 4 times 4, negative 16 equals what? Negative 32? A physicist would tell you there's a lot of applications of these dot products. One application is if you have two vectors whose dot product is 0, then they're called orthogonal, which mathematicians don't say. Mathematicians say perpendicular. If two vectors meet at 90-degree angles, then their dot product is going to be 0. Right here, the dot product isn't 0, so these two vectors aren't meeting in 90-degree angles. What about this one? Find the dot product of U and V. I like the ordered pair notation better than the I and J notation. Like U equals 3I. My habit, if I'm just going to sit here and do this, I'd write it as 3, 0, dot. Negative 4, 2. And now is it like number 8? Well, yeah, it's even better than number 8. You don't have the same number appearing so many times. You go 3 times negative 4. That's a negative 12. Then a plus. 0 times 2 is 0. So negative 12. Okay. Number 10. Have some of you taken a physics course? Maybe taking one right now. Do you remember your teacher when the things were bolded like this? What would they do? Would they try to denote something, do something special to make it bolded? Again, the most common thing is when writing that U, maybe put a little ray over it, something like that. Let's see. Here we're told evaluate the expression 4U dot V. There's a W here that's listed that we don't even need, do we? Right, we don't need that W. I'm just going to go ahead and write the 4U. That would be 8 and negative 4 dot B That's just the 4, 1. I'm just recopying that. So let's see. You multiply the 8 times 4, 32, plus multiply the -4 and the 1. So -4. So what are we getting here? Is it 28? That's all it asks. Oh, wow. Number 10. Excuse me. Are you all caught up? Number 11. U dot V minus U dot W. How many dot products are you going to find here? Say 2. 2. And then you're going to subtract. So you're going to get 2 numbers. The U dot V will give you a scalar. The U dot W is going to give you a scalar. And then subtract it. So I'm doing, let's see. I'll do U dot V. So that's going to be 5, comma, -1, dot, 5, comma, +1. I wonder if y'all will wind up with so many of the same numbers popping up. So I'm doing the U dot V, sort of the order of operations, same as the order of operations for real numbers. You would multiply and then subtract. So it'd be 25 plus a -1, so 24. Now U dot W, five, comma, -1. And what is it? 1, comma, 2. So what do we have? A 5. I'm multiplying 5 times 1 plus -1 times 2 is -2. Oh, is that going to be 23? I don't know why I'm trying to squeeze it in there when I have all this extra room down here. So U dot V was a 24 minus U dot W, 23. What number am I going to put in the little box? Why is it 23? Oh my gosh, why is it 23? Oh wow, so for the last recording of the semester, I really make a silly mistake. Thank you for pointing that out. Okay, I'm going to correct it this way. For that 23, it shouldn't be 23. It should just be 3. So I'm going to mark out that 2 there. Then I'm going to come up here. Y'all were so quiet, I should have realized something was wrong. Mark it out. So what should go in the box? 21, yeah. Unless I messed up somewhere else and y'all aren't telling me. Did I mess up anywhere else? Oh, wow. Well, I sort of hate that that's the last one. Okay, well, typical. Thanks for pointing that out. Okay? This is just a short assignment introducing you to vectors and dot product. As far as applications, we'll have to leave that to a physics teacher. Okay? There's that's no longer listed as a topic in this course for the academic course guide manual. Okay? So, nice short assignment. Signing off for the semester right now.